Hi, welcome to tonight's presentation. We're going to have a also workshop style coding afterwards, so I'm going to try to not make this too long. I can talk about the subject for a couple hours, I think, because I worked on the project, but and I'm going to try to keep it short. But if you have questions, don't hesitate to interrupt. This is what I'm going to show you. First, a small review of the application, then some mentions of notable data structures or libraries that I used in the project, a short note about supports and testing, some pros and cons of Elm in this particular project, and some I'm going to try to relay some conclusions that came up at the project last retrospective concerning Elm. Yeah, so let's dive in. First, the demo of the. Can you see all right? Like the text size is fine and everything. Okay, so this is an application, a single-page application to be used by surgeons to do two things. One is to prepare an operation. So that would be with this view here. You name your operation, and the operation is composed of two types of blocks. One is a procedure, so a procedure is something that you do, and a check is something you observe. And you group, take a pre-made one just to make it easier for us. So here I have this operation template. This is the library. I can add new blocks on as I wish. So as I said, either a procedure or a check. Checks don't have an extra description, so this block disappears. And to build stuff, you just drag and drop, and it groups blocks of the same type in a group. And of course, I can rename stuff and like give the groups estimated durations, because afterwards this template is used during an operation, and you see this live, so it's good to have an estimate of how long something takes. Right, and well, the Elm debugger is kind of in the way, but there's a, if I move the window away, there's the cancel and save buttons here, but let's just take an existing operation. So I then go here and I can run through the operation. So what happens? I have the current time in hours and minutes, the total estimated time of the operation, and you know, depending on if you're late or early compared to the estimation, you also get this feedback here. And here you really see the steps one by one. You concentrate, of course, on one step at a time. And this is hooked to a foot pedal, which acts as a keyboard. So while the surgeon is working, they don't need to touch the tablet. They can just press and continue. But also, if someone is assisting, they can click on either side of the screen to go up and down. So you'll notice that here I have the first step, which is a procedure. And if something goes wrong, I can flag this. This will become important later. Otherwise, I just go through the operation, have a summary at the end, and I save it. And here now is the completed operation. With this, I can write a report. So this text is pre-filled from the descriptions of the various procedures, and I can add some stuff here, save it again. Like this debugger thing is a bit in a bad place in development for me, but on this project especially. But anyway, you save a report, you just text for now for the MVP. And there's another feature, which is when you flagged that something went wrong, you can go back and report the incident. This incident report is important in this project because they want to learn from mistakes, but do it anonymously, so get feedback without putting blame on people. And there's this form which you fill in to describe what went wrong, Of course, this validation, this is using Richard Feldman's validate, which I found very, very nice. And something that I'll allude to later that I can show now. For instance, we have these checkboxes here, like is this event is this preventable? And if you say no, well, you can't give any more feedback. But if you say yes, an extra field appears, and and if you had, well, here we had just one incident, but if, I don't know if I have an example with more, well, I have to run an operation, but then you just click next and you submit the next form. And, you go to the next form and then you submit all together or nothing at all because of privacy reasons. But anyway, I can show more stuff, but that's more about the business, well, the domain of the application, not so much about Calm. So I'm going to go back to the presentation. Some statistics about to give you an idea of the structure of the application, or the size rather. It's a little shy of 5,000 lines of production code. We have 1,300 lines of tests. There's some JavaScript. A thing that I didn't show was, where is it here? I can search for stuff, so yeah, and this is using a solution, a JavaScript library called Lunar.js, and there's some solutions in L, but I thought this one was the best at the time I evaluated, so I used this, and there's some JavaScript to just hook it up to the Elm application. Yeah. There's some styles because we decided to go with external style sheets, and just as a point of reference, there's the counts for the backend code. I think there's a lot more tests comparatively in the backend because since it's an API, we not only make assertions about the shape of the response, but also about the content. So if you have, I don't know, some piece of, well, something that would return a JSON blob of 60 lines, then maybe you have the same structure in Ruby to compare it directly, or maybe you have like 50 assertions on the contents of the fields, stuff like that. So that wouldn't be the same, I think, in every kind of project, and especially if the project grew, it would look a bit different. But I think it's also interesting to see the ratio of a technology where we are more comfortable and technology where we're newer and are not always sure what to test or how to test things. Some cool things I used, which I thought made sense for the project. One is, well, I wrote the names of the modules, but like you can look up those libraries. One is list selection. It's a thing that it's a data structure representing a list where at most one item can be selected. This comes in here. So this is a list of things. I can click on one and I display it. What's nice about it is that, well, one alternative way I would see of implementing this is keeping an index, like a pointer to the current element of the list. But now I suddenly have these two pieces of data that can get out of sync. But this list, this selection data structure keeps the selected elements always up to date. You can just go forward or backwards or select another one, and it will. You're sure that you never go out of bounds, and you also don't need any extra. Like here, there's no duplication. I have just this list in the model, and it knows which element is selected. So then in the view, I can just derive what preview I'm going to show, and if nothing is selected, I show no preview. I think it works nicely together. Another one which is very similar is a select list. It's just the name of the other library, and it's about always having exactly one item selected. This can be seen in this view in the operation, because we always have something focused, and if we want to modify some data, for instance, flag something, or I keep track also of the length. So when I go to the next one, first I I change the metadata of the step, then go to the next one. And so this I can do easily because my data structure, like my nested data, is represented like this kind of select list, so that I always know which is the current item, and I don't have to play around with maybe types or something like that. I don't know how clear this is, but I'll show you an example of. I believe this is how. Well, this is like the internal representation. So if when I start the operation, I have my list of steps and stuff. There's nothing preceding the first step. Then there you have the current element, and then you have what comes after. And in my use case, I wrote a function which would advance the list. So you just go like this, and you can not go past the end, or you can decide however you implement it. In general, I believe this is called a zipper. So a zipper is a data structure that allows fast access to a selected element, a current element. But here we have a list. It's also a simpler example, but you can imagine a tree of things, and you pinpoint to one node of the tree, which is the current node. And if it's already the current one, you can quickly update or delete or whatever. And you always have a reference to things that are before and things that are after, so that you can traverse your data. What happened in my use case is that we have groups, and then those groups have steps. So when I go next, I not only go to the next group, but I also go to the first step of this group, and when I go back, I need to remember my position that was like the nested thing in the top level thing. So I had to add some my own implementation. So those this represents the operation in the view that I just showed you. It has some metadata, well, some data of the operation model, if you want. And also the important part is here, this groups field is a group zipper. So in the operation we can traverse the groups, and in each group we can traverse the steps of this group. And you can see that I'm just reusing the select list implementation. I'm not inventing anything new here. And this thing, it doesn't have anything fancy. The nesting is only 2 levels, it's a list of lists, if you like. And for this, I needed to add some functions, which are maybe not well named, but I understood them in the code, and they're consistent, at least internally. So something to transform from and to this kind of data structure. And the two operations to go back and forward, because they were not provided by the underlying library, but it was easy to implement them and to update the selected things. So the library might have map, but maybe you don't want to map over each element, just the current one, so I implemented this. And I also implemented a lot of stuff on like I added some functions to those libraries. I also added some things to the list library, and I didn't name this list extra because this is already a package that exists. And yeah, there's a lot of extra. I also used these packages, and sometimes in list.extra I used maybe, I don't know, 10 functions or so, but in result maybe I used one and date one. So it's always a trade-off of, do you want to implement it yourself, do you just pull in the package? I do think that it's great that those libraries exist, but they're not, let's say, not as curated as stuff in the standard library. So sometimes you can see that people had problems and they solved them and they put them all in the same bag. Especially with lists, there's like 100 functions in there. Yeah, some other techniques. I just cherry-picked a few. One is really trying to avoid booleans, because booleans are bad. Booleans are bad in every language. I think they make function signatures unreadable. They make the code itself unreadable. Like, what does it mean to have true as an argument? So I have a few things in the code base which looks like this. They're still binary values, but they're named according to the domain, and you can never misunderstand what you're talking about in the code using something like this. Something else is, okay, so this is the thing I showcased before, where you had could this error have been prevented? Yes, no. And so in the no case, well, that's it. And in the yes case, you also give a description of your strategy to prevent the error. So this is a very simple example of those nice modeling opportunities that Elm gives you to forgo booleans, flags, and all these kinds of things, and just have your data in a way that's clear to you, but also prevents you from making mistakes, because of course you have to handle both cases in your code. A big one was drag and drop, and it was a big one because there's a lot of edge cases. You can, if I go back, you not only drag blocks from the left, but you can remove a block, so you drag it back. You can, you combine things if they're of the same type, but also you can move this entire group somewhere, and it will, does it? Yeah, you order stuff, and if you move a thing, it drop zone is wrong. Okay, it creates a new, like, there's all these cases to handle, and I used a library which extracts some of the HTML5 drag and drop behavior. I think fixes a bug in Firefox internally and that kind of stuff. But still, and it's not a very complicated library, but it's nice that it exists. And what you do is you need to store in the model something which kind of well, this is an opaque this is I haven't showed it, but the drag drop model is something that's opaque but takes care of the current state of if you're dragging or not, or over a certain element or not, and all that kind of thing. And eventually you get messages about, oh, this was dropped in this drop zone, and it was this original element and stuff like that. Makes it really nice, but still there's a lot of edge cases in this context, and I'm glad that I was solving this problem with the Elm, because it it took me maybe 2 days to consider all the things, and then you go back to the interface and but there's a bug here. Why doesn't it drop? Like, why doesn't it add the element when you drop it there? Oh, okay, I forgot this. Like, oh, I forgot. What if you drop a thing below the other thing, but above the next? Where should it go, and how should elements regroup, and not leave the copy behind? But all these kinds of things. And I think there I initially was excited to see it work, so I implemented a bunch of stuff, and then found some bugs, and then go back to the basics, write some unit tests, and then I quickly found that all of my bugs were in the view code, where I had mistyped the thing or inverted two arguments where they were like the source and destination, that kind of thing. Those can also be prevented with types, I know, but not in all cases in this code. Ports. That's everything that there is. Something to store the tokens, the auth tokens in session storage, or session storage or local storage. and then all the stuff that comes with Lunar.js, where you have to first index the stuff that you want to search through. So in our case, the documents were just those blocks. A thing I followed here is to not use strings or basic types in through the ports, but have just the JSON value and have a dedicated decoder to handle this afterwards. It gives a little bit more flexibility, I found. Yes, tests. Overall, the experience with testing was good. Since it's a single-page application, and the backend is even in a different language and all that, I used JSON Schema a lot. So JSON Schema is JSON Schema is a way to specify the structure of a JSON document. So I'm sure you have you have those kind of things with XML, right? What's it called?
Schema.
So?
XML schema.
Yeah, XML schema. I don't know.
XSD.
Yes.
Did anybody say so?
Oh yeah, it's XSD.
Don't ever use that word.
Right. So I use this, and I'm just going to show one part of it. But in general, for the specific case of Ruby, I wrote a blog post about about having a shared schema between your front end and your back end, and have it automated so that if you mess up in one part, the tests there will fail or so on. But we can talk about this later on. In this application, on the front, in the Elm side, I use JSON Schema in coordination with fuzz testing. So if you have a piece of JSON here versus the authorization token, you can write a schema in Elm. It's just like a DSL of sorts, even though it's plain Elm. And so this structure just says, okay, title is something that's just human readable, but then you know that you have an object. This object has a required property named data, this one. Then this data object has a required property named token, and then the description is for you, and you can add some other things like examples of data that conforms to the schema, and then you can run a tool that generates the JSON files representing the schema. Look up JSON Schema if you want to know more about this. Right, and the way you use it is that then you can take the schema, generate some JSON values that conform to those schemas, but they're filled in with random data as in all fuzz tests. And then I test my decoder to just see if it works correctly. In this case, I don't have an encoder, otherwise I would have maybe also mirrored them.
Do you generate the decoder in Elm also from the schema, from this DSL?
No, I don't. I hand-wrote the decoders.
Okay.
It's actually, right? It's a plan, but also somebody's already built it, so perhaps, I don't know if you still need to, there's this site called QuickType where you can take different kinds of inputs in the sense of data descriptions and generate kind of encoders and decoders in various languages for it. And so one of the things you can do is you can feed the JSON schema and it will generate a decoder for you. And then you are basically, you don't even need to write a test because it's already guaranteed to be, the decoder is already guaranteed to be compatible with the schema. So that sounds, I think it's called QuickType.io or something. Do you know?
What is it out? Oh yeah, and for simple stuff, it's or not simple stuff, but for some cases it worked. And I don't know if you've tried doing this. Like in the case of, okay, I have the operation, then the operation has a list of groups, which each has a list of steps and so on. And so I happily wrote a first test and then pushed it, and this happened. Like Circle CI ran out of memory on while executing this test. So then I quickly reverted to an example test instead of a fast property-based test. Yeah, that was not a great.
Are you using and then in this one? Just not and then.
I just did the same thing as here, just giving it the schema for the other thing.
Okay.
There are things that you can, like not using lists of lists, which you probably use with this.
Yeah, I know. I mean, I understand why it happens. It's just I was so so enthused to do it, and then
There is work on that, I think.
yeah.
This is.
Right. Some things that I very much liked. I mean, I've been doing Elm for 1.5, 2 years now, but this is my first project that actually went to production. I've written prototypes before, but they never ended up going to production. So I really tested the whole thing from beginning to end now. Something I really like is Elm format. It's amazing, and it's also amazing for collaboration. I like debugging a lot. The Elm debugger helped me, especially with the drag and drop stuff. Sometimes it was really hard to understand what's happening when you have a user action that cannot be well translated into an automated test, because you can test the logic of move this from here to here, but like actually clicking with the mouse and dragging it's much easier with a good debugger. Although one thing I don't like with the debugger is if you have long message names, it shortens the name, it writes an ellipsis, and so with this abbreviation you cannot easily see what's happening. And if you have a lot of steps, so for instance on drag and drop, when you move the mouse it generates like a bunch of events, and then you have, if you want to see which one changed the state how, you have to hover with the mouse in the debugger to see the complete message. It's not great from this perspective, but it was, I mean, it's fine, but it could be better. I really love the pipe operator, like what is it? Forward application operator. I use it a lot, and I think it really makes code clearer. I had a colleague who even complimented me on my Elm code, and I said, well, it's nothing special, just how Elm is written. But I have to agree, I really like this style of writing. I like the tooling, so with this is more like a side thing, but it was easy to set up Elm with Rails, because nowadays Rails comes with a gem that wraps webpack, and it was basically run 2 commands to set it up, and then you have stuff like hot reloading, which was really nice. The feedback loop was really good. I already have what is it? I mean, Elm format and I think also on make running in Vim when I save, so that already gives me feedback. But to have the thing on the side, especially to see compiler errors and details, it was very useful. And also in the case of everything goes fine and you've modeled you've modeled your application in a way that from the current URL you can really deduce the entire state of the screen, then when you add something, you see that small change and don't even have to touch your browser. I think that's very good. Yeah, refactoring. At one point, so okay, some background. I tried to not over-engineer things, and so I started with just a main.elm file, and I extracted small things here and there. For instance, a tile that represents remote data with different loading states and so on. Stuff like that, I could immediately see, okay, this I can extract because it's kind of a library, but I didn't care too much about extracting different pages of the application or different parts of the view or stuff like that. And at one point, I think it was around 2,500 lines, I thought, okay, this is getting difficult to navigate, so I'm going to refactor and extract modules for the different parts of the application. And this was the diff, and it took me like 2 hours or 3 hours because I don't know, it was just it changed the entire application basically, but it was easy in a way. I like it's something it's a bit like leaving breadcrumbs. So you make the one change, and then you can go home or go for lunch, and then you come back and you know exactly what you need to change. You just change the next thing that fixes the topmost error. And yeah, that's very liberating, I think, when you don't need to take notes about what you need to do next and keep all of this stuff in your head. What happened to me most of the time was, okay, now I want to make this refactoring, and I'm going to try to make it, and I just never think about the edge cases. I know that the type system will help me detect those as I make changes. I don't know if that makes sense or if you had this experience, but this is something that happened to me. And yeah, and you can really be methodical just by following the hints of the compiler, and this gave me great confidence in the day-to-day work and also in the quality of the software. And it was a project that was on a very tight deadline, but somehow with this tooling I felt very confident, very serene. Yeah, and I could just continue working. So there were also some downsides, or some annoyances, minor annoyances for me, but bad points still. One thing was not always knowing how to test things, or what to test and what not to test, because I've done a few projects, but not enough projects of a sufficient size to understand that, okay, if you don't test this, then maybe you'll get bitten by it later on, or not in production, but later on in the life of the project. Questions like, okay, so do we test the logic of the update function, what messages go in and out? And in this case we didn't, but I tested a lot of the business logic about the transformations on the data, which I think makes sense. I also tested the decoders. I tested some of the extensions I made to those libraries, because when you're working on a generic function, it makes sense to test stuff.
Did you test that drag and drop state machine?
No, well, I don't remember. I didn't test the whole thing. What I tested was different edge cases of moving something somewhere else. But this takes as an argument the data structures and not. So it was not a complete approach of. Well, maybe it was. I think I covered most of the cases, but maybe I forgot something. That's also where. Since it's example-based, you can only be as good as you're good at QA in general. I think there's some opportunity there to also write property-based tests, but it's also, as I said, a project where I was in a hurry and it would have taken me more time to figure out how to do it well. Yeah, speaking of testing, so Node Test Runner is one of the libraries that backs Elm Test. And I had two problems on CI with it. One is that it detects, well, there's a known issue where the wrong number of CPUs or cores is detected. And so by default, the tests run really slow unless you... Actually, no, what was it? You install a utility that reports the right number of processes or threads that you use. And so then it works okay. And the other thing is that when I started the project, the version of Elm Test, or specifically Node Test Runner, would randomly hang on the CI server and even on my work machine. And I think this was fixed recently, but it's one of those things, you know, on that point version, I had this problem, and it was unfortunate to have to spend a day trying to debug stuff and not. What happened there is, usually I would have maybe taken the last known good version, but the previous version did, like, it was a breaking change between this version and the previous one, and the previous one did testing in a different way, and I wanted to be feature compatible. So I took the latest one and used the fork and like somehow hacked around this constraint, and I made it work in the end. Sometimes I got seg faults from webpack, which wasn't great. That's not that often, but still, I was surprised it could do that. Of course it can. Yeah, and speaking of webpack, after a while the hot reloading became a bit slow, so I don't know if this is just, you know, Elm may takes a while and starting from a certain size, if the hot reloading interacting with the Elm compiler works some way that's not efficient, I don't know, but it came to a point where, I don't know, right now with 5,000 lines of code, I have to wait maybe 3 or 4 seconds before I see a change, whereas of course in the beginning of the project it was instantaneous. But overall not very big gripes, I guess. On this project it was, on the development side it was just two developers, me and a coworker. And he has a reading knowledge of Elm, and he has written some Elm as well, but he's much more proficient in React, for instance, whereas I don't know anything about React and have a bit more experience in Elm.
It's just like Elm.
But yeah, we had to make a choice for this project, and we chose Elm. And what we discovered is that onboarding takes time, a lot of time. I don't know how to word this. It's maybe silly to expect also someone to jump right on the project where they haven't written production code before and be efficient. But it's something that there was some slow parts in the project because of this, which was okay because every project is a learning opportunity, and we paired, and like there was no problem from the understanding of the code, but my colleagues' feedback was, well, when I sat down and wrote some code, I didn't know how to model something or handle the edge cases and stuff, and I would have been much more efficient in React. And I think that makes sense, because when you're comfortable with the tool, that's why I was efficient with Elm. So overall, that's a general, I think, conclusion, not only about Elm, but when you try new technology on a project. Still, the project was small enough that it was okay to compensate. And what we ended up doing is, he ended up doing a lot more of the back-end stuff, and I ended up doing a lot more front-end. And it worked out. But from a personal perspective, I was eager to introduce. Well, we had already used Elm like one Elm module or two on a project, and this was our first project that was almost completely Elm, and I was eager to try that. And when it's not enough when one person is enthusiastic about something, there has to be consensus, and sometimes it's better just to use the tool that everyone knows instead of introducing something new. And yeah, that's it. I have some references. I didn't really. So I drew some inspiration from the Elm single-page application example by Richard Feldman. In the end, the structure ended up looking similar, but I avoided explicitly starting out like this because I think it can get complicated if from the very first module you try to build a framework around your code. And so yeah, if you were to read the source code of the app, we can look at it, some of it later. Some areas look very similar to this code base. I like Richard's talk at Elm Europe. It embodies some of those things that I used in the, or rather the code I wrote embodies some of the concepts that he presented there, which I know just overall good tips for Elm applications, I think. And not so much direct inspiration from this talk about how to unblock yourself with Elm, but more the approach to solving problems. For instance, if you get stuck, how to ask for help, how to make it work with the tools you have available instead of trying to force Elm. So how to use force and just write some JavaScript, be done with your day. That's it. Yeah, thank you.